All right, this question is asking us about experimental probability for a single experiment. And so what we have is here just one die that's being rolled, and you have an experimental probability question as something that has just happened, or Beatrice has just rolled this die 36 times. Remember, experimental probability, as in the notes down here, is based on what actually happened. So what just happened in the experiments, whether it's 1 time, 36 times, or 3,000 times, the experimental probability is what just happened. And so in this particular question, what we see is that it's a 6-sided die, 36 times, she rolled a 3 5 times. So that would be 5 out of 36. So 5 out of 36 would be your fraction. You could reduce that if you needed to, and that would be your experimental probability. Now the next question says asks for you to predict how many times she will roll a 3 if she rolls it another 18,600 times. Now that is going to be based on your theoretical probability. So that is not what just happened. So these past 36 trials do not matter whatsoever. It's based upon your sample space, which is this die has 6 sides. So what we predict to happen or what we expect to happen is based upon the theoretical probability. Theoretically, what should happen is that you should roll a 3 1 out of 6 times, right? That is the probability of rolling a 3, right? So that's 1 out of 6. That's based upon our sample space, equally likely sides of a 6-sided die. And then what you do is you multiply that by your 18,600. So you take your 1 divided by 6, and then you multiply that by 18,600, and what you end up is 3,100 times. So what we expect to happen, or what we predict is going to happen, is that she's going to get 3,100 threes in the roll. So you completely ignore the experimental probability when you're trying to predict what's about to happen for the theoretical probability.